Here's a fun one for today, guys. Multiplication with exponents. We're going to discover a really handy little shortcut when we're multiplying variables with different exponents where we share the same base. So let's get started. Here's one where c times c squared. Now if we were to write this in expanded form, in other words, get rid of the exponent, just write it all out, well, this would just be c times c times c, right? We had this first c from there, we had the c times c there. Well, c times c times c, right? Well, that's just c cubed. All right, so far so good. Let's sit down and look at this one and group it. I've got n cubed, right? So I've got n times n times n. I've got three n's. Now the second one here, I'll say that's n times n. Okay, well, all right, that's great. Let's now put it back together again. I got 1, 2, 3, 4, 5. Okay, so that's n to the fifth. All right, finally, let's do this last one here. Y to the fourth. Ooh, this is starting to look like a lot of y's. Ooh, boy, y times y times y times y. I'm not liking this. There better be a better way to do this. Okay, this is starting to get to be a real pain. All right, let's count them up. 1, 2, 3, 4, 5, 6, 7. Okay, so this is y to the seventh. Okay, like I said, this is starting to get to be a hassle and we don't even that many exponents. Well, what do you see? You know, there's some patterns here. In particular, let's look at this. Now, let's start with the second one because maybe this is a little more obvious. Here's a 3 and a 2 and a 5. How do I combine a 3 and a 2 to get a 5? Well, hey, I know that one. How about 3 plus 2 equals 5, right? That's kind of cool. All right, here's a 4 and a 3 and a 7. Let's see if we get the same thing. Sure enough, hey, 4 plus 3 equals 7. Ooh, I like this pattern. Now here's a 3, but where's the 2? Oh yeah, that's right. Right, when it's just the variable on its own, this is like having the number 1 there. So we got the same pattern again. Look, here's a 1 plus a 2, right? We've got 1 plus 2 equals 3. 1 plus 2 equals 3. Well, that's awesome. Okay, so here's how we're going to do it in the future then. We're not going to expand it, do all that extra stuff. The way we would write these in the future is we're just going to add whatever the exponents are, right? Now, remembering that if there's no exponent, that's like the number 1. So this would just be c to the power of 1 plus 2. Well, 1 plus 2 is, of course, 3, right? And this one we do the same thing. We just think, oh, look, n to the power of 3 plus 2 equals n to the fifth. And again, remember what the exponent means. The exponent means, it doesn't mean I'm multiplying 5 times n or n times 5. What it means is I'm multiplying n 5 times, right? That's what we did in this expanded form up here, right? N to the fifth means multiply n 5 times. Notice there's no 5 in here, is there? Right? There's no 7, there's no 3, there's no 4. It's the number of times we multiply it. That's what it's telling us. Okay? Same thing happens down here, right? So again, here's our handy little way of saying this. We're going to say y to the power of 4 plus 3 equals y to the seventh. All right, cool. All right, so that's our baseline. That's what we do when it's just the same variable. If, on the other hand, we've got multiple variables, right? If we got different variables showing up, we're going to use the same concept, and but we're going to have to be a little more careful on how we do our work. Now, what you notice when it's just one variable, I was just working sideways because that's fine. That works real easy. But I find that when you have multiple variables like this, you're actually better off to work vertically if you can. Okay, now just so we don't get confused, I'm going to cover up this one. I just want to do this one on the left here first. Okay, so I've got this right here, which is c d squared times c to the seventh d to the ninth. Now, I know what would happen if I had just the c's and just the d's. Now, these are different variables, though. See, so I can't, this is not c d to the third or something like that. I can only combine them when they are the same base. So I'm going to rearrange these. Remember the commutative property of multiplication? In other words, you can move things around, right? It's like, you remember, right? 5 times 3 times 2 is the same thing as 5 times 2 times 3. Remember, you can move things around as long as they're multiplied. You can do that all you like. Okay, so here we go. And again, you notice that I've got a dot here meaning multiplication, but when we have variables, we don't actually have to have the dots, right? So I could have it, there might have been a dot, there might not have been a dot. I might have used parentheses between the terms. There's a lot of different ways that we represent multiplication. So here we go. I'm going to put the C's together. So I've got C and I've got C to the 7th, right? C times C to the 7th. Now I'll just throw a dot there just to make the separation obvious. Now just to make it super obvious, I'm going to put the D's together. I'm going to put parentheses around there just so we don't get confused, right? D squared times D to the 9th. All right, and again, the dot there is kind of optional. I'm just doing that to emphasize the separation. Now that I've got them together, I can think about each thing on its own, right? So first, I'm only going to think about the C's, right? C times C to the 7th. Okay, so that's C to the power of 1 plus 7. Okay, same thing goes over here. D, so this is D to the power of 2 plus 9. Okay, D to the power of 2 plus 9. Right? Now notice what we're going to do here is add them up. So I get C to the 8th and D to the 11th. So there's my answer for that one. Right? And again, see what happened here. This is like saying C to the 1st. That's why it's C's there's 8 C's, and then D's, there's 2 plus 9, there's 11. In other words, if I was to expand this all out, I'd have 6 C's in a row and then 11 D's in a row. Also, one little thing too, usually we try to have these things alphabetical. There are some exceptions, but all else being equal, you're probably going to see variables going alphabetically. Okay, let's look at the next one over. Same idea, we're going to do the same thing here. Okay, but this time I've got a 0 power. Now a 0 power, m to the 0, is really just 1, isn't it? So I could just ignore that term, right? Because that's like saying 1 times. So I am just, but I'm going to show you the other way I could have done it, right? So let's just do it this way and say, look, this is m to the 0 plus 4 times n to the 5 plus, now again, this is like having a 1 here. 5 plus 1. So you get m to the 4th times n to the 6th. And there is our answer again. And again, like I said, you could have just ignored that if you want and said, you know what, hey, that's just like the number 1. And I could have just said, look, well, there's only an m to the 4th there. And sure enough, I would have gotten the same answer. All right, let's look at this very last example where we've got even more variables. And again, the more variables, you have to be careful. Again, it's just like we did before, but you just want to really be careful with keeping track of everything. So let's just see, and I'm going to highlight this just so I can keep track of this, just to really emphasize what's going on here, just so we don't get confused. Right, let's just think about the a's. Look, this is a to the 0, a cubed. Now, you know what? I'm just going to use that shortcut before. Look, a to the 0, that's just like the number 1. So I'm not even going to bother with that. And look, c to the 0, that's just like the number 1, isn't it? Right? So really, when I think about the a's, all I've got here is a cubed. Here's a cubed. Now b's, yeah, I'm going to have to combine those, right? Here's a b 2 plus 4. And then finally, again, the c, this is just like a 1 again. And we have a c. Well, again, I've got a cubed, b to the 6th, and c. Last thing, I do want to just point out what I did here. You'll see it back on this previous page. And I just wanted to kind of make you mindful of this. Sometimes I put parentheses up here, sometimes I didn't. And it's really, you know, it really comes down to how neat and clear you can be with your work. If you can make it really clear what the exponents are, then you don't really need the parentheses. But if you get a little sloppy about it, then parentheses can be helpful just to keep it straight where the exponents are and not the number. But again, do make sure it's really clear that this is an exponent and not just a 4 in front. All right, well, that's it for today, and looking forward to our next video with you.